Hello everyone, this is the 7th video of the Dynamic Programming Algorithms video series. In this video, I will introduce the longest common subsequence problem and show how to solve it by using dynamic programming. A sequence is a collection of objects in order. Let's start with a simple example. Consider two sequences. The first one is B, C, A, D, B, and the second one is B, D, C, A. The common subsequences of them with a single element are B, C, A, and D. Since the elements of subsequences don't have to be consecutive, the common subsequences with two elements are BC, BA, BD, and CA. Lastly, the one with three elements is BCA. So the longest common subsequence has three elements. Our aim in this problem is to find such a subsequence for a given two sequences. The longest common subsequence problem is important because it's commonly used in bioinformatics to find the similarities between two DNA sequences. A similar problem to this one is the longest common substring problem. In that problem, different than this one, the substrings should contain consecutive elements. To solve this problem, one of the methods, probably the worst one, is brute force. Basically, we enumerate all subsequences of one of the sequences, let's say the first one, then we test which ones are also subsequence of the second sequence. Finally, we pick the longest one. If the first sequence has n elements, it has 2 to the power n subsequence. So brute force is an exponential time algorithm. To develop the polynomial time algorithm, we will use dynamic programming. Let's start with notation. We will denote the sequences by x and y. The length of x is n and the length of y is m. So x is a sequence from x1 to xn and y is a sequence from y1 to ym. Lastly, Lij is the length of the longest common subsequence of sequences from x1 to xi and y1 to yj. So, L and M is what we are trying to find, as it's the length of the longest common subsequence of x and y. Now, it's time to compute L and M using a dynamic programming algorithm. In the first step of the algorithm, we initialize Li0 for each I from 0 to n and L0j for each j from 0 to m as 0. Then we iterate over each element xi of x and yj of y in a nested loop. If xi and yj match, we can extend the longest common subsequence for the sequences up to xi-1 and yj-1 so that Lij is equal to Li-1, j-1 and plus 1. If xi and yj do not match, we cannot extend any longest common subsequence so that Lij is equal to maximum of Li-1j and Lij-1. Lastly, we return L and M. In terms of the structure, it's a simple algorithm. Its time complexity is order of n times m, as we iterate over sequences from x1 to xn and from y1 to ym. And its space complexity is also order of n times n, since we must store L for each I from 0 to n and each j from 0 to n. Now, let's code this algorithm in Python by writing a function called LCS. The inputs of this function are sequences x and y as lists. First, we compute the lengths of each sequences, n is the length of x and m is the length of y. Then in the first step, we initialize the length L as a dictionary. We set Li0 to 0 for each I from 0 to n. And also we set L0j to 0 for each j from 0 to m. In the second step, the outer loop iterates the elements of x and the inner loop iterates the elements of y. In these loops, we update the length Lij. Lastly, we return L and M, the length of the longest common subsequence, as an output. To implement the algorithm, let's solve the simple example I described at the beginning of this video. This is how we initialize the inputs values x and y. X is a list with elements B, C, A, D, B, and Y is also a list with elements B, D, C, A. When we run the function with these inputs, we can obtain the length of the longest common subsequence of X and Y. As you see, we cannot obtain this sequence because we didn't keep track of it in the code. I believe that it would be a good exercise to keep track of the longest common subsequence in the code so that you can obtain it at the end. Also, I should mention that this dynamic programming approach is not the best way to solve this problem in terms of the space complexity. With some modification, we can improve our approach by decreasing the required space, but I don't explain here how we do it. If you have any question about it or something else, please leave a comment. In this video, I talk about how to solve the longest common subsequence problem by using a dynamic programming algorithm. I hope that it was helpful. In the next video of this dynamic programming video series, I will introduce the matrix chain multiplication problem and show how to solve it by using dynamic programming.